Alright, so we should be live for real now this time. I'm sorry about that. I'm trying to figure out YouTube still. So what I did is I created a event and I also started a live stream at the same time. So there was like two things going on at the same time. So we should be back. I'm going to redo the intro real quick for the VOD. Basically, what we're going to be doing today is we're going to be making a third-person character controller along with a camera and just make a gym around it. So maybe like try some platformer mechanics, how they jump, add some multiple states where maybe your character could hang on top of buildings and just, stuff like that. Basically, we're just going to see as we do it. But I'm going to be sharing with you guys the code I've made in the past. It's a code I was quite proud of and I didn't want to share with you. I was a little bit selfish, but now I will because, hey, nothing to lose, right? Okay, and I see people tuning in the live stream right now. It's not showing. It's actually, I think it's showing now. It's because of the glitch I just said. Can I add the Discord link in the description? Of course, I will add the Discord link to the description. Let me quickly just pull it up, and here it is. It's like I said, the Discord is something quite new that I plan on using instead of using Facebook, since I am getting spam on Facebook and I have no way to control it. I can ban people, but they just keep coming back. So we're going to be copying this, a never expire link, and putting it in the description. I don't know if it's actually being refreshed live, but it's there now. Else it's going to be in the chat. So it is working fine. Yep. It is live now. Amazing. Okay, so everything seems to be going perfect. We are going to get started right away. Since it's a project I've already kind of done in the past, I'd like to improve it. I have something right here, but we're going to be redoing it. So, Subway Surfer is something I'm not going to be doing today. Today is like the Sunday fun day where we just have fun, build something fun to watch, because Subway Surfer is not going to be fun to watch for a little while. But it's definitely something I'm working on the side, that's for sure. Mehmet, I do not speak your language. I am sorry. What is Discord? Discord is a voice chat application. It's just like some kind of Skype, but a lot of people can tune in. And the reason I'm tuning in Discord on top of Facebook is because Facebook is like everything is directed to me when it comes into messages, and that kind of sucks because there's a lot of messages and I have to go through it like everything. However, if you go like in programming help and you ask question in here, I'm not the only one receiving the question, so other people might be able to help you, and that's just, hey, that's amazing. So I'll be looking at these things quite well later on, not right now, because right now we're doing a third-person character controller. And let's just read a little bit more comments before we get started. So the entire stream will be viewed later on YouTube. Yes. Zoma like game. I don't know what Zoma is. Can you put a link to that game? Thank you. Zeno, what about a multiplayer one? We're gonna start by getting a player moving around the screen before we think about putting that in a multiplayer state. So let me focus a bit. I'm going to create a new scene real quick. That's going to be our gym, not a game. That's going to be a gym. And here's what I'm going to be doing. Creating 3 folders, one being the scripts folder is the first thing. Then everything is going to be contained into something I like to call motor. But this time it's not going to be a simple player motor script like in all the tutorial. It's actually going to be quite a big site machine. So if I just get a little bit deep in that, we're going to create another folder, called it state, and we are going to start laying down, say, the base state, the base motor. So let me explain to you what type of technology we're going to be using. We are going to be using a state machine, and on top of that we're going to be using inheritance. Since multiple things could have the same type of control as us, we don't want to be limiting our controls we make, this whole script we make, we don't want to be limiting it to the player, because we might want to be using it for NPCs, for net player, for other actors in your scene. What I'm doing right here is I'm creating a base motor that is going to have like the base mechanic, and on top of that when I'm done with this, I'll be creating a player motor. So this one actually reads the input as well and then runs the base motor function. If it would be something like an AI or NPC, the AI or NPC would be like AI motor, and it would inherit, of course, of base motor. But instead of reading inputs, we would actually just feed them AI inputs. So just calculate stuff and then make decision based on that. Cool. So let's get right into it. I'm going to be pulling the other project on my other screen so I can have a look. So no reading comment for a little while. I'm sorry. We're just going to get started right away. I'll be opening that in Sublime, yes. And here it is. It's a big script, guys. It's not a small one. But in the end, it's some really nice technology that I'll be sharing for free. So where should we start? Well, the first thing I'd like to say is that this is going to be using the character controller, so might as well initiate it right here. We initiate it in a start, so private void start controller is equal to get component character controller. There's going to be more to it as well. So the way it's going to work, since this is a state machine, everything, like every single movement and every rotation your player should be having at the moment is going to be passed through a state. So that's going to be another script somewhere that's going to be calculating where our player should be and also what his rotation should be. So before we even go further in the base motor, we're going to go ahead and start creating a base state just so we can have the type around. So let's simply create a base state script, and this one I will actually remove everything and just leave it like that for now. We don't need anything else, we just need the type to be available. Okay, so I'm trying to go in an order that you guys will understand, but I think that's gonna be quite hard. Quick thing real quick. We're not going to be putting that on private since we want to be using it on the player motor and the AI motor as well, so we're going to be putting that on protected. We need a protected base state. That's going to be the current state your player is in. And when we start, we are going to start by adding a walking state, I think. We could do walking state, so I'll just say initiate the state of our player to walking state. Of course, right now we don't have that type just yet, so we're just gonna put that on the ice, and I am going to create the update. So private void update. Now this is where we have the typical loop going on, so let's actually look at this. So first thing we need to do is ask the state, ask the mobility state. Well, ask the state where we should be, or where we should actually, okay, let's reword that. Process our input vector to get a delta position. That makes more sense. Same thing, of course, for the rotation. So process our input vector to get a rotation. Now, when I say process, it's really what I meant. So you're going to be taking your state, and you're going to be like sending your state a vector 3 of your inputs on the keyboard, and then this one, the state, is going to be like, okay, so since you're jumping right now, I don't really care about your inputs, you're going up. Or since you're falling right now, again, I'm going to discard that you pressed left or right, we're simply going to go down based on the force you had. Okay, so we'll go like this. Then something that is really important to do on every single frame as well is to check if we have any transitions. So look if the state needs to transition. I don't even know if that's English. So assuming that you're walking around, then you're jumping, that's fine. When you're falling, say, we have to check every frame. Okay, did you hit the floor now? And if you did hit the floor, we go back to a walking state or running state. Okay, that sounds good. And then we're gonna use some other function right here, protected. We'll put those virtual in case we have to override them. for both move and rotate. So protected virtual. Let's do void rotate. Those are of course to move and rotate. I'm gonna be putting them right here in the update. So move and rotate. Here we go. Let's do a little bit of comments reading while I take a sip. It's too late in Taiwan. I know. I'm trying to stream like early, but waking up in the waking up in the weekend is kind of hard. I'm overslapping with the major in Final 2. Well, I don't know what's going on right now. I know that PewDiePie is streaming too, so I just wanted to make a live stream this morning because the last one yesterday went a little bit weird. Was not expecting that amount of views. So this is more casual. I like it. How long the stream is gonna be? It's gonna be as long as we finish this thing because this is really aimed towards getting a nice VOD at the end. So VOD as in video on demand. Yes, it will be available later on. Okay, this happens when we upload. Yep. Yeah, the Discord link is gonna be in the description, guys. You can join there if you have like big question. When you're falling, you can move left or right. It depends. It really depends. What type of game are you making? Sometimes you don't want the player to be able to control when he's like falling. Sometimes you just want him to go straight down. Yeah, it's morning right here. Alright, let's go back to coding this thing. So, we're gonna grab this. We're gonna grab also a directional input. So depending on what you press on the keyboard, you're gonna get like a vector tree, a normalized vector tree. And we are going to be calling it move vector. This one is gonna be public vector tree, move vector, and that's gonna be a property because that's what I like to do apparently. We're also gonna have a quaternion for the rotation quaternion. It's gonna have the exact same thing as well, I mean it serves the same purpose as the move vector, but of course for the rotation. And down here I also have a input vector, but should I actually add it? Yep, let's add it as well. Public float vertical velocity, and this one is not going to be a property apparently. If I just base myself on the old code I did, it's not a property, but it is a hide in inspector, so I can't actually see it. Let me explain to you real quick what those are. So move vector is going to be the result in the end. So say you're running, you have a speed of 5 and you're just pressing on W, so your end vector is going to be 0, 0, 5. Rotation quaternion is simply going to be, well, what is my rotation right now? So that's going to be the rotation of the player basically. Input vector is what you press on. So if you press on both, say, A and D, you end up with a vector 3 that is 0, 0, 0 because you're canceling it out. If you press A and W, then you end up with -1, 0, and 1 because you're going left and you're going forward at the same time. It never goes beyond 1 actually, so it's not going to be -1, 0, 1. It's going to be a normalized version of that. Vertical velocity is going to be the speed in which you go on the y-axis. So if your vertical velocity is at 10, then you're going up. Basically, that means you're jumping. Or you're falling, depending on which side you're going, of course. And I'm simply going to be like, there's a lot of more fields. If I look at this, there's like too many fields in here, but I'm simply going to be starting with what we have right now. And I'll try to shut up and try to concentrate a bit. So we have the state. The state does not do any processing right now. I mean, we only have the comments. So what we'll do, let's head over to the state real quick and create our functions in here that are going to be public and virtual because we need to override them. So every single state is going to have the same exact thing. Every single state needs to be constructed, and that is a simple state machine design pattern. So construct, is that how you write it? This is how I'm going to write it. Public virtual void destruct. So if you can figure this out, construct is going to be called when we enter a state. So say you're entering the walking state, then you'll have access to a walking construct. Now when you're leaving it, you're going to have access to another function right here. Now everyone also needs a transition, and that is like the most important one. They also need the process rotation. So let's do public virtual vector3 process motion. Let's go with motion first. That takes in a vector3 input, and finally a public virtual quaternion process rotation that also takes in a vector3 input. Okay, so with these things here, well, first we need to return something, so let's return input right now. Return quaternion dot identity. Okay, every single state, depending, like if you were on the walking state, or if you're in falling state, if you're in riding a horse state, they're all gonna have these 5 things right here. Now they're all virtual, so technically we already defined it for them, but you'll want to be overriding it for every single state because they're gonna have like different behavior. Process motion is going to take your input on the keyboard. It's also going to know your motor, so it knows exactly where you are right now. It's gonna have more parameters, such as say the wall vector you're hitting, the floor vector, the slope. It's gonna have all that information, and based on that information, he can actually calculate where you should be on the next frame. Okay, cool. Let's go back quickly in the update. We're gonna be changing our comments right here to something like that. So move vector is gonna equal state process motion, and we send in the input vector like this. Now the quaternion, the rotation quaternion, is gonna be equal to the same thing, but we process the rotation instead. Send in the same exact input vector. We might want to change that later on if we have multiple input vectors, such as say the left joystick and the right joystick. Left one would be controlling the movement, and the right one would be controlling the camera, so we'd have to swap these over here. But we don't need that for now. And I've also got some code right here to support moving platform, but I'll be adding that at the very end. And basically that's all we need to make it work. I'm sorry. I'd like to actually be putting the inputs right here, but we're not sure if the base motor is going to be a player or NPC, so we're not going to be putting it in the base. Let's see what the comment says while I drink this hot chocolate. Shouldn't be the update protected? Yes, it should be. I'm just copying very poorly. Protected virtual void update. It goes the same for these thing. Yep, they're fine. Let's keep on reading. How is your job? My job is amazing. I'm learning so much stuff. I was about to say a bad word. Which is a favorite game I've made? It's something that you haven't seen yet. Yeah, we're not really working on Subway Surfer right now, so I know that when you're following Subway Surfer, you can go left and right, but this is not what we're doing today. We're just making like a gym with some technology I had lying around. Do I work in the game industry? If so, what is your salary? Your salary is gonna depend on where you live. It's just a normal programmer salary. You just put the normal programmer salary in the area you live, and you're gonna get the same exact thing. Your first app you release has 30k downloads. That is amazing. That is just amazing. Alright, let's keep on working. If you guys have like I see big chunks of question. If you guys have some big question, you can leave them in the Discord. Again, the link is in the description, but I think it's only going to be appearing when the live stream is over. So I'll send you another link right here. Okay, so we're back. Let's have a look at this. What do we have? We have move vector, that's fine. Let's actually code our move function. They're quite simple. The move function is simply... Oh, it's actually a little bit more complicated than I thought. Okay. Thing is, when we do a controller.move, I don't know if you can actually tell if you see the little pop-ups, but collision.move returns you a collision flag, which let you know where your player is colliding. So in the code I have right here, we're keeping track of it to know, okay, so are we hitting like the top of our player? If we are, then let's stop jumping or something like that. Time the delta time. Okay, so we're gonna be keeping track of the collision flag. I'll call it call flag, and we're gonna be declaring it at the top. So let's go for public collision flag. Again, set and get, we want to be accessing it later on from the base state. What else do we need in the move? We also keep track of the wall vector in the move. So wall vector, and I don't know if I should be putting it right here. Well, we're gonna be putting it later on. We're gonna come back to that, I promise. And finally, in the rotate, transform the rotation is equal to the rotation quaternion. I'm building this up step by step, basically. So we're gonna have to come back and actually fix some things here. Okay, cool. So this is what it looks like right now. We're gonna go ahead and start coding our very first state, so we can have a look at how this plays in the game. Now this is the base state. Let's go for how could we call them? Just walking? I feel like they need some kind of prefix in front of it. But you know what? Let's only leave them plain words like that. So walking is going to be our very first state. And it's going to inherit from base state. Let me quickly pull up the walking state just to see what goes on in the code there. So every time you create a state, you make it inherit from base state. You're like, okay, so you already got 5 functions in the back defined for you. Now you need to override them if you want to do something specific. So in this case, we want to be overriding the public, the construct. So public override construct. I also override the in this case, what is it? Process motion, and also the transition. Okay, cool. And I just realized that I'm missing one thing in the base state. I'm missing a link towards our motor, which we do not have right now. So how do I go about defining it? I'm in the base state right now. I do a protected base motor, and this thing I actually assign it in like some kind of a wake. So private void awake. Motor is equal to get component type of base motor. Okay. There could be like a better way to do this. I am sure of it. This is old code, but I'll figure it out later on. I like to figure out things later on when they actually crash. Your first app has 80k downloads. Hey, my apps don't get that much. They'll get like less than 50. But it's okay, I haven't really monetized anything, I haven't really tried. I've been lucky enough to have jobs left and right, so. Okay, cool. So we're back right here. We have the motor. Since it's protected, we can access it from this state. And we want to be keeping the base.construct here because that's where is it that where we get our reference? No, we get it in a awake. Okay, so we don't need to keep the construct. Okay, so check this out. When we enter the walking state, we're gonna kill the vertical velocity. So we're gonna be making sure that, okay, so you just enter the walking state, you're not falling and you're not jumping anymore. You are literally just on the floor and your y-axis does not move. Now in the process motion, this is where we do the maths. So I have a bunch of things right here, like bunch of helper function. I don't know if I should be sharing with you guys that thing just yet. It might be a big step. You know what, let's actually just do something simple. So we're receiving inputs from the player. We need to transfer that into a move delta. So what I'll be doing right here is simply input times, say, speed. As simple as that. And let's have our speed instead of the walking state, so private float walk speed. Let's put that on, say, 5. And we return this thing. Also make sure that the input is normalized, so normalize. You guys saw the code. It's a little bit more complex on this end because we do more operation. And don't worry, we're going to be doing them by the end of this VOD. But basically, the kill vector thing, it does, if you're running into a wall, like what usually happens like in games when you program your own, like your first character controller, when you run into a wall and you have, say, a forward vector just running towards it, and sometimes you get stuck inside of the wall because your player still tries to enter, like to go through that wall basically, but it gets stuck because of the collision. What the kill vector is if you go straight towards it and you hit like the perfect angle, it's gonna remove everything. So technically in the game you're not moving forward anymore. If you go like at a 45 degrees, it's only gonna kill what it needs to, so you don't run into that wall basically. But in the game it's gonna look like you're like stuck to it, but you're not gonna be really stuck. If the floor beneath you falls down, then you're gonna fall with it. The follow vector is how to explain. If you're walking downhill, instead of actually just jumping like in Unity, if you've made your control before, if you're going like in a straight line and the floor is going like in a slope, then sometimes it goes like this. So it goes forward and then you fall, and then forward, then you fall. It's just to prevent the fact that if you're walking downhill, you don't get into a falling state. You actually just keep on walking but following the ground. Apply speed is a simple method that takes your magnitude and multiplies it. I'm definitely just running out of breath talking like that all the time. Hey guest, can you make a tutorial? Hey guest, you're kind of weird right here. You're asking me to make a series of multiplayer FPS, but then you say that you just want to learn programming. It's harder than we think. When we start programming, it's harder to make multiplayer games than we think. I mean, the game we're currently working on is simply a gym, so basically we need to have something that moves and have it like a camera at the end. That's the only goal of this stream. Let's do we have enough to just get started right now? Let's have a look at this. So we have a base motor. The base motor is not taking any inputs from the player, so that's definitely a big problem. We do not initiate the state, so let's go ahead and do that. How do I go about doing that here? get component walking. Okay. State is equal to get component walking, and then we call the state.construct. So that means when we create our player, it's gonna need a few things. It's gonna need, let's see, it's gonna be needing not a capsule collider, it's gonna be needing a character controller. Right now it's gonna be a base motor since we don't have a player motor, and it's also gonna need the walking state. Now having all of this, whoa, what happens to this camera? Why is it like this? Okay, that was weird. So we have this player right here. Of course, it's not taking any input, so we're not gonna be moving. But I feel like this code is running in the back. Amazing. We don't have gravity either just yet. Let's shut down the lighting real quick. There we go. That's not it. And we're gonna go ahead and start creating our player motor. The only reason I want to do the player motor right now is just so we can have some inputs and test it out. The player motor, since it inherits from base motor, is actually quite small. So we have the update motor, something we already have right here actually. And we have this pull input function, so I'll just be copying this over since it's very long to write for no reason. Create a new motor script, and that's going to be the player motor. Alright, so let's make sure we inherit from the base motor. And now at this point, we need to get the direction. This thing right here that's only like directional input on the keyboard, so I'll be using input.getAxis horizontal, and also input.getAxis vertical for those. We go in X and Z. We're not using Y because you know Y is up and down, so we're only moving forward or left and right. Forward, backward, left and right. We also normalize it if it's bigger than 1. I'm using square magnitude because when it goes beyond 1, I don't know how to explain this in English basically, but square magnitude, if you're only looking at something that is bigger or smaller than 1, magnitude and square magnitude is going to work for this. That's the only thing I have to say. Bunch of things I'm trying to explain, but like my English is still not on point. I'm like struggling to talk right now. Okay, let's before I go ahead and read some more comments, I'm simply going to implement some movement state so we can actually see it moving. And I think I'll revert back to what I had in my previous code. Instead of using a update, I'll be using a update motor, and then in here, private void update. This is where I'll call it, because I don't want to be overriding the normal update. I want to be overriding this thing here. Okay, so this is what happens when you are an NPC. So basically this one is kind of void. It's kind of useless for now, since we're only working on the player motor. However, we're going to be copying over to the player motor. And in here, it's not a protected override, virtual. It is a protected override because we're overriding the previous one. So this one it becomes completely useless. It's not useful anymore. Let's have a look at the loop I've done right here. It is a we start by getting the input. Start by the player input. So we do that by doing a vector3 input is equal to pull input. That is the function we have down here. Oh, you know what? We actually have an input vector for that. Input vector is equal to pull input. And then we do something interesting that I'm going just to write right now. Rotate the input vector with the camera direction. Something we can't do right now because we don't have a camera. Well, we do have one, but we can't really control it. Okay, and then we do a move vector is equal to process motion. We're now taking the inputs we have on the keyboard, we're sending it over to the process motion. Then same thing with the process rotation. We check for state. Oh, we don't check for state transition. My bad. Here we go. And then finally we do the moves. And rotate, of course. Okay, let's have a look at this in the game, see if we can actually move left and right, of course, without gravity for now. And we can't. The only reason we can't is because we're using a base motor. This thing is not supposed to work on its own ever. You know what? Since I don't want this to work on its own, we're going to turn this into a public abstract class. Which basically means you can't be putting that, like, it can't work by itself. This thing needs to inherit, needs to be inherited from. So, if you check my capsule right now, we have this and our script is totally broken. We have to remove it. Let's put a player motor on top of it, and now it's gonna work. Press play. We're going left and right, so we have the basic movement going, but it's working under our state machine, which is to our advantage. Let's quickly read some comments while I take my breath back. Yo, Gillum, I don't know how you had like that much download on your application if you didn't even advertise it. That's just crazy amount. Should be proud of that. Oh, show the code you're writing when you answer comments. Yeah, sure. I'm sorry about that. I mean, we're gonna be jumping like a lot. And if you guys tune in the Discord, we're gonna be sharing the actual code in the Discord at the end. So let's create a new channel for that, shall we? This is the Funday. Amazing. Let's do everyone. It's not working. Okay, so everyone sharing the Funday code here. Later, of course, when it's completed. Whoa, there's like a bunch of people in Discord. That's amazing. I'm gonna have to start looking into getting a bot for this thing. So I have a question about Zen. I don't know what game like Zen is, so I'll just Google Zen game real quick. Or you know what? I'm getting some weird Zen garden stuff. So if you could please just like send me a link toward the chat or in Discord about this Zen game you're talking about. That would be amazing. Tomorrow I won't be able to talk. I don't really talk that much in real life, so don't mind. Yeah, I'm streaming on Twitch sometimes, but I'm mostly streaming games on Twitch. Like when I play some League of Legends or Heroes of the Storm, I do it on this channel right here. Fairly small. Don't really like, I'm not super active, but hey. Sometimes it's fun to just play games with people. It's line Zen, okay. Let me Google line Zen real quick. Another game by Ketchup. Amazing. So how do you make physics? The question was, how do you make physics like this? I'm gonna need some gameplay video. Let's look at this guy. Best high score. This looks like a simple add force, to be honest. Oh, okay, you're most likely talking about this thing right here. To be honest, I don't know if it's being controlled by the tilt of your phone. I'm not quite sure. Actually, it said it over here. So, touch and drag to move the dot. Okay. His best eye scores suck. Like, what the fuck? Why do you post this on YouTube? I'm gonna be honest with you, I really don't know what's going on in that game. I see a lot of like the little balls that were falling, they're all like physics material, that's cool. But you have this like built in Unity. When am I live streaming again? I'm trying to live stream on the weekend, that's the only time I can really live stream. Um, I want to be live streaming on when I get back from work sometimes, but I know that this is really not a good time to do it. Well, since everybody in the US is live streaming, and also like most of my audience is in EU and also India and the Philippines, so that's not a good time when I get back from home. Hmm. Yeah, I totally roasted this guy. I wrecked him. I bet I can beat his high score in like 3 seconds. Alright, let's go back to let's go back to not dissing people online. You know what this needs? This needs gravity. Now, how do you implement gravity? You would go ahead and just have this walking state right here and do your whole logic in this. That would be like the whole plan. But since we're lazy and we might be using gravity at other places, such as, you know, falling state or jumping state, we're going to be coding it somewhere else and actually calling it from the walking state. So what I had right here is that I had something called a motor helper. So this thing is my motor helper. It's gonna have a lot of function in it. Sorry, helper function. And I could actually just take this whole thing and copy it over, or we could go one by one. You know what? We're gonna go one by one with the two screens open. Talk about some efficient coding right here. So we're not gonna be including the well, I'm not gonna be including Sumerian for this, but you can do it if you want. Public static void apply speed. Apply speed. Basically, what it does is it's gonna be taking in your input vector. In this case, this one you send in the reference, and it's going to apply a speed. Can't tell you much. That's basically it. Oh, there we go. I can actually shrink that. Amazing. Quick note for those of you who are confused right now. We have a parameter that has a reference in front of it. So right here, reference, vector 3. It means that whatever we send in, like in parameters, is going to be, well, might be modified by the function. In this case, the vector we send in is actually being modified, and there's no return value. There's no like this is not calling anywhere else. It's simply taking the thing that is in parameter, the reference parameter, and multiplying it. And doing that, you're gonna get a result somewhere else. So if I head back to say the player motor, oh sorry, the walking state, I can only do right here. Let me put that in full screen. Motor helper dot apply speed, reference input, and also walk speed. I can only do this like that, and return input. Input has been modified. Everybody's happy, and everything works fine. Okay, amazing. Let's go back to the motor helper. We're gonna speed this thing up. Boom. Apply gravity. Gravity. How do we explain gravity? Simply, just take an apple and let it fall from a tree. We have the reference vector 3, that's the one we're going to be modifying, of course, and then we take in a reference vertical velocity because we're going to be modifying that as well. Let me just try to explain it as best as I can. Actually, you know what? I can't. You can just read this. It's fairly simple, right? You take it, minus equal gravity. If you go beyond a maximum, so a maximum terminal velocity, so that means if you're falling at like a speed of 10 meters a second, next frame it's going to go for like 11 meters a second. But if your terminal velocity is minus 10, then you're going to be stuck there and you're always going to be falling the same speed. This is due, like, if you're falling into an abyss, into a game, so like an infinite void, your player doesn't end up going at like 8,000 meter down a second, because that would be crazy and not really realistic. So you have a terminal velocity to just cap your falling speed. There it is. So that's the word. Terminal velocity is to cap your falling speed. Amazing. And finally, we just, yeah, that's fine. Okay, so vector3.set is the exact same thing as doing vector is equal to new vector3. So this is just redefining what's inside of it. And okay, so cool. For some reason we return the vertical velocity, but I don't think I ever use it anywhere. So this could technically be void. But if it's there, it's most likely for something. We'll find out later on. Let's keep it simple for now. Next, kill vector. Oh, that's one function that took me a lot of time to actually figure out when I was a little bit younger in my programming life. So this is the one I was talking about. So if you're like running straight towards a wall, you're not gonna like keep that velocity towards the wall. The wall is gonna be like cutting it, so your vector is gonna be not as long. If you're running straight towards a wall, you're gonna be ending up with a vector that is 0, 0, 0. This way you don't get the glitch where your player gets stuck in a wall and you're supposed to be falling or something. I gotta breathe a bit. Change the description to Sunday morning. I like the fun day. What's wrong with Funday? Funday Sunday. What is Funday? It's just us doing a little bit of everything, you know? Okay, that's our kill vector. I'm not going to read it. You can read it. That's the math I've come up with in the past, and it worked out fine. Nice. Full vector. This one is really interesting because we're doing a cross product. So how to explain this in the simplest way? We have the reference vector, which is, you know, what we're going to be moving with in the end. That's always going to be there. And we have the slope normal. So if your floor is like flat, then your slope normal is vector 3 to up, because that's the normal of your floor. If your floor is like tilted this way, then you get a normal vector that is like this. Using these two, then we can do a cross product to know that your vector is going to be straight in a direction, in the z or x direction. And then using the slope normal, we can actually just rotate it like this, so it follows it instead. And I'm making some weird things right here. Amazing. Amazing tutor. That's running out of breath and out of voice. Hey Yasin, what is going on? A lot of people from India right here. Is this for Android? No, it's not for Android. Rotate with view is simply just to take my camera direction and orient my input towards it. So if your camera is actually looking behind you and you press on W, you want to be going in vector 3 dot back, basically, not front, because you're looking towards the back. Oh, Saturday morning. Whoa. Yeah, you're right. You're right. I just got roasted. Amazing. Kill vertical is simply an operation that removes the y-axis and your vector. And phase direction is returns a rotation facing. Okay. So basically, you're gonna have your move vector at the end. That's your move delta. Phase direction is simply going to take the orientation of your player and put it towards your move direction. So that's our motor helper. Everything is static in here, so we can use it like without having to call an instance, which is amazing because when you're making your states, you don't want to be writing too much code. You want to be keeping these clean. Now, if I go back real quick to the walking state, we have kill vector first, and now we won't be able to complete it just yet because we're missing some information. But let's do motor helper. Kill vector. We have the reference input, as always, and then the vector to kill. That is the wall vector, if I recall. Yep, motor.wall vector. Information we do not have right now. We'll leave it like right here, but put it in comments. Then we apply the speed. Okay, so motor helper. Sorry, we already applied the speed. We have to apply the slope. So follow vector, reference input, and finally the slope normal. This thing, again, we do not have either. So when we do our move and when we do our ground check, which again we don't do, we're gonna have to keep track of two things. When you're running into a wall, you need to know what is the normal of that wall so you can kill the vector. And when you're, say, going downhill or you're just on the floor in general, you need to know what is the vector you're currently standing on, what is the normal you're standing on. So are you standing in a slope? Are you standing on the flat surface? Are you supposed to be standing? You know, that kind of stuff. Right now all we have is apply speed, so that's kind of boring. Hey, but it does what it has to do. By the way, the reason we don't have gravity is because this is a walking state. We're not really taking care of gravity in a walking state. We'll take care of it when we're falling, when we're jumping, but when we're walking, don't need gravity. Good morning, y'all. Yes, somebody from the East Coast. Yes, good morning. This is what we are on right now. Morning. What is the spec of my PC? I'm running something. How do I check spec? I never really did that before. I'm running i7 3.2 with 16 gigs of RAM. And my GPU is, I don't know. It's been a long time. I think it's a 970. When should you use references in parameters? I usually use references when I need to return more than one thing. So if you guys, if you remember, motor helper, apply gravity. For apply gravity, I need to return two things. I need to return where I'm supposed to be, so the reference input in here. But I also need to return the vertical velocity. Since you cannot have two return parameters, then I put it in references. But I could go ahead and just, you know, say something like, okay, so input is going to be equal to this. We don't need a reference. I'm simply going to return it in apply speed. But since I've just, you know, since my whole code is based around reference right now, I'm just gonna leave it like that, and I actually like it better this way since we don't like have an assignation right here, a assignation, you know, that kind of variable. Control panel dot system info, sure. I don't know where system info is. I'm a noob. There it is. Oh, I'm actually running 3.6. Hey, I don't even know my own computer. Amazing. And 32 gigs of RAM. Okay, well, that's cool. Yeah, about Spanish, I don't speak Spanish, I speak French, so technically I could understand you if you speak to some degree, but I can't speak it. I also gotta be fixing this issue where we have bad video settings apparently, and the stream is not healthy. That's what YouTube telling me all the time. All right, let's keep going, guys. Let's finish this thing. So I have an option right here. Do I go and actually create those parameters? Do I actually keep track of the wall vector and the slope normal? Or am I going to start coding the transition? Because right now we're walking, but we're in the middle of the air, so that's kind of stupid. We should be falling. We're gonna go with the transition real quick. Yeah, DXDAC for the graphic card, I know that one. So I have a 970. I knew it. Amazing. Tout le monde parle français. Alright, so let's get the wall vector and the slope normal. I'll be taking these off real quick, and they're not gonna work until we implement it. We want to be implementing it in the base motor. And also the slope normal. So what I did is I created two new properties at the top of my script right here, and they're gonna be like simply holding the data about the floor and also the slope. Now the places where I get them are quite tricky, to be honest. The first place where I get this thing, say the wall vector, is inside of the move function after the flags. So what happens is we do a wall vector is equal to, and then we do a nice bit operation that is going to confuse everybody, and I can't really explain. So did we hit aside? If we did hit aside, then oh my god, okay, I just realized that this code is not noob friendly at all. I'm so sorry, you're just gonna have to copy this line, I'm not explaining it. I'm not actually assigning the wall vector right here. I'm only resetting it. If we're not hitting anything on the side, if we're not hitting a wall, basically it checks. Okay, so if we just move right now and we're not hitting a wall, put the wall vector back on 0. If we did, just leave it how it was. And I'm gonna be looking at my code. Where do I actually assign it? I don't assign it anywhere. This is not working. My old code is not working. This is the only place where I assign it, but we're not really doing anything. Oh well, we'll have to we'll have to figure it out later on. Amazing. Now, as for the grounded function, sorry, not the grounded. As for the slope, so to know what is the normal you're currently standing on, this thing is actually calculated when we check are we on the floor or not. Now the function to check are we on the floor or not, if you use Unity, you're gonna know that controller has a function called is grounded. But this thing is so unreliable, it's awful, like it's really bad. It is, I've never seen something so unreliable as the is grounded from Unity. So we always end up creating our own public virtual boolean grounded, and we use this instead. It is quite a big amount of code, so you know what, I'll be copying this over. I'll be just dumping it in Discord as well, and we'll go over explaining it real quick. Hey, Funday. So is there a way to actually edit code? In Discord, let me quickly Google that. So use the 3 backticks and you can make multi-line code block. Okay, I'll be trying that out. enter to save. Whoa, it's something and it's awful looking. But hey, let's go over explaining this real quick. Amazing. So what I do to get to know if my player is grounded or not is I actually use a raycast. I use a total of 5 raycasts, which is quite expensive, but let me actually tell you that it's not expensive when you're on the floor. It's only expensive when you're jumping or when you're falling. The reason is what I do is actually take like a lot of vector 3 point based on my character controller, so it knows exactly where it is that my player is, and it's gonna like take the bottom of my character, pull the bottom of my character just a little bit up, and then shoot downwards. That's what I call the middle point. So starting from, imagine that your player was like a square. If you were like in the top view, your player would be a square. You know what? We have Unity. We can actually just show it right here. Imagine that your player is just like this. What we do with the first raycast is that we start from the middle, and then we shoot a ray downwards. Which, if it works, then we do a return here, and we don't have to run the rest. If it doesn't work, it moves on to the front right. So front right is now here. We are shooting a ray from there downward to see if we're actually hitting something. And it just goes on like this. So basically, if front right doesn't work, front left, then back right, then back left. Okay, and it takes some parameter right here, just some floats, constant float that I use. Let me actually just copy them over. Here they are. So distance grounded is I think that's the distance of my ray in total. So I'm shooting a ray downwards. It's gonna be 0.5. Now the inner offset is that before I actually shoot it downward, I bring it up a little bit just to make sure that I'm not below the floor. It's really complicated to explain with words. I wish I could just do like drawings. I wish I was good in art in general. So our ray, they all start like at the base of everything. They all start like bottom right here. And then what I do is I give them a inner offset grounded, which just pull them back a little bit inward like that. So 0.05, which is not a lot. And then we go with a 0.5 distance, which would be around like that, right? So just remember that we pull our ray upward a little bit, and then we shoot them back again. The only reason is that if you're on the floor, that's a cube, that's not a floor, but we'll have to deal with it. Yes, yes. Then if you start from the bottom right here, it works fine. However, if you're in a slope and you're like this, then what happened is, so this one is gonna hit true, this one's gonna hit through, but this one over here is gonna hit false. The only reason is it's because it's actually starting inside of the cube and it's ignoring the face at the top because it's beneath it. So that's why we give it a little push upward. Okay, let's have a look now. When we do hit something, we grab the thing we hit and we check for the normal. This is where our slope normal comes in. And then afterward, we check, okay, so it's that slope, is that slope normal beyond our slope limit? So I think we put 55 degrees. If it's above 55 degrees, that means we are currently sliding or falling, depending. If you have a state for falling, or sorry, for sliding, that's cool. If you don't, then just put falling. Yeah, so we just copied over this big chunk of code. Amazing. Good times. What else are we missing right here? Can we actually hit play on this? Where are we? Oh, I broke everything. I believe that I broke everything because it's killing the wall vector. And wall vector is nothing? Okay. Before I start debugging this thing, we're going to keep on working on the states. Let me quickly look at the chat. On parle tout français, yes, yes. I don't know what the game Ballsy is. I'm totally sorry. Like, I don't play games that much. I only play like competitive multiplayer games because that's what I'm into. I've mentioned in my last video not to go to school. That's true. I I mean, I think that you can actually learn by yourself. However, if you need that push, if you need like somebody to push you constantly, like to force you to deliver something, then school is definitely good for you. However, if you don't need that and if you have the discipline, then just stay home and pick up tutorials because that's as efficient as going, sometimes more efficient than going to school. I believe it's actually more efficient than going to school. Some places are going to be dicks though. Some places that want to only hire people are from school. Some people are like that, but in the game industry, I think experience and things you've done in the past is worth a lot more. You hope to see more live stream. I'm trying to do more live stream because those are so much better than just making regular videos in terms of like the YouTube stats. So that's like I'm winning a lot by doing this. Not in terms of money, but in terms of just minute watch. Hey, Happy Farang. Yeah, I'm back at streaming already. I mean that's my weekend, so I'm hoping to stream on the weekend. Here we go. Here I am. I should collab with Brackies. Yeah, I should collab with Brackies. You should tell him that. I'm definitely down to collab with Brackies. Everybody's trying to get networking working in their game. We had a stream, a weird stream that I've done on Twitch where we kind of tried to make this happen. However, I can't just sit down in one session and make a whole multiplayer server. Like, it's really complicated to just, like, one session, make a whole multiplayer server. It's not gonna work, and also, like, the needs are going to change with everybody. So, right now, on my end, I'm working on a multiplayer game that is actually in 2D and has like some basic movement, and the whole architecture and building around it is good for me, but it's not gonna be good for everyone's game, basically. What Discord server am I using? I am using my own Discord server actually. I should do a Q&A stream. Yeah, I will. Sure. Soon. Later tonight. Why not? Hello from South Africa. That is cool. Nice. Hi, what's up, Game Over? I will claim you learn faster by yourself than in school. That is totally true. You cannot donate. I'm not here for donation. But yeah, you've been supporting me on Patreon, so thank you so much. By the way, about Patreon, I'm about to shut it down. This thing is really annoying. It's quite good. Like it's supporting me. It's supported me in my harder months when I was trying out YouTube and actually going super serious about it. But now that I have my job, I don't feel like it belongs there anymore. I feel like I can support myself through my own income stream. So of course I wish I could just like get free money and clear all my debts in one go, but at the same time this goes against like free education. It doesn't go against free education. It's just okay, the real reason is that Patreon pisses me off because people just they pledge, they get the stuff on there and then they leave. So it's like thanks, dick. And that's why. Instead, what I feel like doing is in a little while, if we can see that like the stream is working and everything is good, I feel like I'll just be taking down everything from Patreon and I'll just leave it on my website free of charge. And it's gonna be like donation based, so people that want to donate, they can donate. If they don't want to, they can still grab the code and do whatever their school project with, basically. Hello from Italy, what's up, Italy? Marco. Anything you learn in school is obsolete within a year. I would almost agree to that, else I would knew how to rig and how to do stuff like that. Okay, let's go back to coding a little bit. Good question though. Like I'm enjoying interacting with you guys a lot more than answering question on Facebook. So we're going left and right. We need to go into another state right now. To go into another state, we need to check for the transition. So when we are walking, what is it that can actually make us switch from walking to, say, falling? The reason, not the reason, but the answer is quite simple. So if motor is not grounded, if you remember, we do have this function now. So if we're not grounded, we need to change to a falling state. Two problem here. We have no means to change states, and we have no falling state. So we need to implement those. Sorry about my burping. I drank too much hot chocolate. It's not really exotic, I guess. This stream is not for exotic people. Falling. Okay, so we need to change state function back in our base motor. Since I'm taking way too long to do this, I'll just be copying over this thing. Oh, also, this is my code for moving platform and also moving platform post move. We'll implement that in a little bit. But hey, in the base motor, change state. Change state is going to take the current state, so in this case that would be walking. It's going to call the destruct function on it, which currently does nothing because it, we don't have it right here since we do not need to have it, but it would be calling this code in the base state. It's not doing anything at the moment. Then it gets a component of the new state, which is going to be falling in this case, and then it's going to construct the falling state, which means that we do need a falling state. So let's right click on state, falling. And this one is going to be so simple since we have everything ready. So it inherits from base state. Then if I just pull it up real quick, we are going to do a public override process motion. In the process motion, we start by killing the vector in case we're like falling, but we're also going towards a wall. So motor helper kill vector, reference input, and motor.wall vector. Cool. Then we do a motor.apply speed, reference input, motor dot we have some kind of falling speed. That's the influence you have on your movement while you're falling. So private float, I'll call it move speed because that's really what it is, to be honest. Like, you're still moving in the air. I don't remember how the walk speed was, but let's put that by half. So 2.5. Move speed like this. And finally motor dot apply gravity, motor helper apply gravity, reference input, reference motor.vertical velocity, and that's why it's public. I just remember. Nice. Motor.gravity, or do we actually need, we could have the gravity on our base motor. That could make a little bit more sense, yeah. So I'll take the same values I had in the past. 25 gravity, that's a lot. Okay, cool. We'll keep it. We'll keep it. Don't mind. Public float base gravity. What I did here is actually had a getter, so that's why it's named that way. In my previous code, what I did is I had all of these public base gravity, but I also had like a gravity modifier on top of it. So where is my modifier? There it is. So what I could do is I would always have the base gravity everywhere the same, and then I would have like gravity modifier depending if you have like if you picked up something, if you are in space, it would go through gravity modifier, and then when I want to get that gravity, I'd go through base gravity plus gravity modifier. Don't feel like we need all of that as of today, so let's just leave it to gravity, public float gravity. It's gonna be public float gravity. We're gonna do a get return 25 just for now. We can add modifier in a future stream. I feel like we could keep on this project. Like, it would be nice if we kept this project through multiple stream and we just keep on pushing the code, and you guys can start contributing as well if you want to. Because why not? Let's just make a bunch of scripts together and everybody can use it. I am definitely down for something like that. Float terminal velocity. Where do I hold my terminal velocity? So where is it at? I think it's also in the motor. Back at the top right here. Public float terminal velocity. And I believe I've put something like 10 in here. Oh, 15. Okay, fair enough. Those values you can change. PMFB, I don't know what that means. Nurk replied, life is complete now. I've replied multiple times to your comments, game over, but sometimes they're just way too long and way too complex. You gotta be using the Discord to ask question. We like to show application. I have no problem with that. Maybe make a PayPal or something. I have a PayPal. I don't like to promote it too much. Because really, I'd rather be making like the money part of YouTube is something I'm hoping for in the future, maybe to go like full time, but I'm hoping to make it through YouTube and not through like fan funding, which just got way harder if you follow the news a little bit. YouTube just like, it's not their problem, it's not their fault, but all the big advertisers just pulled out of YouTube. So that's not fun. But it's just like it's one step harder. It's gonna be possible eventually. Hey, if you ever come back to Asia, stop by Bangkok, I'll buy you a drink. That would be amazing. Hello from Malaysia. So many people from Asia, it's just amazing. When you use a cross-platform input prefab to make it work on mobile, it's laggy. Hey, if your game is ever laggy, guys, if like you have any lag experience, always follow the rule. Well, first, when you develop, always follow the rule like 80-20. So you only need to optimize like 20% of your code, and the rest can be bad or not optimized. You just gotta stop thinking about optimization so much. That's what the rule is all about, because we often spend too much time optimizing that we don't really develop stuff. But in case you run into some real problems, some real like profiling issues or optimization issue, you can always pull down the profiler and look at where they come from. Usually it's quite simple fix. So where is that profiler actually? Right here. So control 7. This thing is gonna let you know what is the bottleneck of your game. If we play mine right now, we can't because the code is not fixed, but it's actually going to show you what takes the most time during one frame, and once you know that, you can actually just, well, first pinpoint your problem and go from there. Usually it's all about like shader and meshes that are way too big for no reason. What I'm trying to say is, if your game lag, just blame your artist. It's always their fault. Okay, cool. I'm back into the following. We have our terminal velocity now, so motor.terminal velocity, and we can return input. Cool. What I did right here is that I also return input plus vector 3 down. Why did I do that? I should not be doing that here. I should be doing that in the walking state instead. It's not necessary, but I'll just be putting it here. So sometimes our raycast tells us that we're grounded, but there's like this amount of like space in between the floor and your player. With this call, it's going to fix it. You're going to be touching the ground, like for real. So that's my process motion. All we need is public override transition. And here we check, are we grounded? If we are grounded, let's go into a walking state. So if we are grounded, motor.change state, and the state name was, if I can stop using my Mac keybind, walking, simple as that. Grounded is a function, so let's put our parentheses here. Back into walking, same thing. So a bunch of code just to get some basic movement going, guys. A bunch of code just to get a basic movement going. Do we get it though? Nope. It says we do not get a reference, and I remember why. That's because we don't have the falling state on top of this guy yet. Okay, let's try this out now. Hey, it's falling. Amazing. You know what I'm gonna do? I'm gonna do something else on top of this. Going to quickly just plug in a debug menu. Well, not really a debug menu, but just like some kind of panel with a text on it that let me know which state I'm on right now. And maybe some more information, why not? So let's plug that up. Top left is always the best place to do everything we have to do. It's called debug, and inside of it I'm going to have a text component. Actually, I'm going to have a vertical layout group with multiple text component in them. I'll make sure to size it first. There we go. So now we can put the vertical layout group. Let's have a look at it while it is playing. Where's my text at? Oh, the height and the width is not expanded. So here it is. Cool. So we have something like this. Let's keep track of the current state. So that's going to be current state. Let's keep track of the move vector, the input vector, the move vector, and also the wall vector and the slope vector. So we're not finishing this stream until all of these are fine. That is my goal. 200, we're gonna have enough space with that, and say 75, 100, 150, 150. Okay, cool. Let me quickly just copy this over so we don't have this awful text looking at us all the time. And I'm going to be setting up this thing in the player motor, because if we have like some AI walking around, I don't want his information to override mine. So I'll be just putting it right here. Private void, not update, private void, update debug text. Debug panel sounds a little bit better. And we're going to have a public text object for all of these public texts. Make sure to include unityengine.ui. That's going to be, let's remember all of them in one go. So that was the state text, the input text, I'm so bad at like everything memory related, wall text, wall slope text, oh, move vector, move text. state text is going to equal state toString. Okay, state text dot text is going to equal state toString. Move text dot text equal move vector toString. Then we had, if we just go in order, we had input text dot text is equal to input vector toString. Wall text dot text wall vector toString, and finally slope text dot text slope vector toString. Slope normal toString. Okay. And we put that right in our update motor. This will display us some dank info. Amazing. Now I need to link those from the player to all of those texts. Current state goes here, the input vector goes there, move vector in here, wall vector there, and the slope. If we press play, we should actually get to see what's going on. So we're currently in the falling state. As you can tell, we don't have any inputs, but we're falling at 0, 15, 15 being the terminal velocity. Now if I press on A, it moves a little bit, and as you can tell, this is my movement, so the movement is really the second one. The one at the top are my inputs. And the two others are for the slope and also the wall, which are always on 0 since we're not hitting the floor and we're not hitting the wall, but I know the wall one is broken. So if we go ahead and we just start creating some, say, a plane. Let's plane this up a bit. Where is our player at? It's right here. Okay, cool. I'm going to put it in the air at the beginning, then create another plane with a slope, and we'll have a look at it in a second. Okay, we're currently in the walking state. If we fall off, we enter falling state. At the very beginning of our game, we're in the falling state, so that's normal. Then as soon as we hit the floor, boom, walking. We're currently, that's our movement every frame. So every frame we're going -1 when we're not walking. This is just to make sure that we're always on the floor. Now when we're moving, we're going at 5, 5 being the the move speed. When we're falling, that move speed is actually halved, so it's 2.5. And then over here at the bottom right here, that's the slope vector. So our floor right now, the vector of our floor is pointing upward because it's flat. If we head over to this one right here, as you can tell, it's no longer just flat. We also have this little X thing, so we know that our vector is no longer like this, it's actually like this, because that's 0.3 in X. Okay, I'm gonna stop with the signs, but basically, it works. Now our only problem is the fact that we don't have walls, so we can't really get the wall vector. Here's a really weird angle. Actually, we're not going to be putting it that weird. Whoa, what does it do that all the time? Okay, cool. I think that's a very cool beginning for State Machine though. I'm enjoying it quite a lot. But yeah, wall vector doesn't work. We need to make it work by the end of the stream. Let's have a look at the comments real quick just to keep up with what people are saying. Here's another way too long comment. So I have it, Yusuf. Okay, so I already answered that. You should really just look into Profiler. If you don't like, if you can't really read the Profiler, you should just be taking pictures and send it over to Discord. We're gonna try and look at what exactly is causing that bottleneck you have. Yeah, Unity default is not really good yet. I mean, they're trying to redo all their default stuff, but like the one you mentioned, the cross-platform input, is not really good. And by the way, Unity is remaking their input system for Unity 6, which is actually not going to be called Unity 6. It's going to be called Unity 2017. What's wrong with donation? Nothing is wrong with donation. Actually, nothing is wrong with donation. I just have like big trouble in my whole life accepting free money. So, hello from Saudi Arabia. I'm sorry, I can't pronounce this country. Like, I can't even pronounce English properly. So, but hey, hello Jaber. If it works, it's good code. That's what I say. Yeah, we have like definition. Like every time you go do an interview about like some kind of programming job, they might ask you, "What do you think is good code?" And my answer is always the same thing. Does it work? Is other people going to be using it? If it works and nobody else is going to be using it, it's good code. It doesn't have to be good looking. It doesn't have to be readable. Nobody's going to be looking at it in the end. So you have a good point. But if you're making like collaboration with people, it has to be readable. That's the problem. In that like in that world, then you have to say that your code is gonna be clean. It needs to have comments. It needs to follow all the nomenclature. I don't know. I don't know how to pronounce that. I'm sorry. The touchpad is laggy, which is used for looking around. I really don't know. I can't really tell since I don't really have a look at it. I can't save you, man. Yes, this is gonna be live after it's done. It's gonna take a little while to render and process, but it's gonna go live and people can follow what we're making. They can't really follow the chat, which is it's kind of bad compared to Twitch, but at the same time, why would they? Does anybody know any AdMob alternative? I would just use Unity ads, to be honest. Wait, how are they going to change the input? Actually, they're going to be like they're going to be changing the inputs in Unity using a whole new system. So if I just go and look it up real quick. They have it up on GitHub. So if you want to be using it right away, you can. However, this is not it. That's funny because basically Unity is making it with people online, so like everybody can like help make the system. And there's a Git link somewhere. But I would read into that post. Again, link his post on Discord. In the Funday section. Amazing. And we're back to coding a little bit. Which is best, AdMob or Unity ads? I like AdMob better because it's with Google, but Unity ad is so much easier to implement and it has a nice dashboard, so they both have up and down really. But the best thing you could do is actually have both of them running, and what you do is before you send an ad to your user, you pull both system and you ask them, okay, so which one is going to pay me most, and you just take whichever pays out the most. That's usually what people do. So based on the CPM and what ad you're getting, that's the one you're going to be showing. Okay, so we're looking into fixing our wall vector, and really I just want to be adding some more text next to that. So let's just say current state is equal to this. Move vector is going to equal to that. So, okay, cool. So we have all this text now. I remember doing this in the past, and what I used to actually get the vector when I'm hitting something on the side was a funky, real funky callback. on character controller hit. So private void on character controller. Does it still exist? Okay, so it's on controller collider hit. There we go. This actually procs when your character controller hits anything. So if you just go and do a debug.log hit.name or gameobject.name, you just walk around with this, you're going to be spam non-stop. So you're going to be playing, and what happens is as soon as it hits the floor, we're hitting the plane. Now if we move over to that plane over there, then we hit the plane number 1, and then let's hit the wall at the same time. We get both calls, so 2 and 1, here they are. We're going to be using this to know if we're hitting a wall or not. So here's what we're going to be doing. So if hit.normal dot, is it x? Okay, now I have to think a little bit, so let's go to the game. If we're hitting a wall, it's going to be creating a straight vector. In this case, that would be vector dot back. The only reason is we're 90 degrees, and since this is the face we're hitting, then it goes like that. So it pushes forward on a horizontal axis from there. So what we need to check is actual the y component of this thing. I'll try to make it more graphic for you guys. It works fine in my brain, but if I just try to make it more graphic using debug the draw ray, hit point, and we do hit dot normal, so you can actually have a look at it. Cool. Hey, that's gonna be quite good actually. Can we actually leave it on for a while? Color dot cyan duration. Let's leave it on for like 3 seconds. Alright, let's have a look at this thing. Right now, you can tell that whatever is cyan right now, this is the normal of the plane I'm on. So if you just like look at this as data, this is 0, 1, 0 because it's starting from the collision point, which is always this thing where you collide, and then it goes totally upward. So that's 1 in y. It's always going to be like a unitary vector as well. If I move over to this side, as you can tell, it just changed a little bit. It still goes it still starts at the same place, but it goes like this. So you have a little bit of x. It's either x or z component to it. It's x actually in this case. So 0.3 in x, as you can tell in the slope vector. So that's the starting point. Then it moves 0.3 in x, which is around here, and then up like that. Now, what I'm trying to do right here is know if I'm hitting a wall or not, because all of these vector, I don't want to be keeping them anywhere. I mean, that's the slope normal, that's fine. But I want to have these over here, this one. This is the one I'm interested in, the actual horizontal one. So I can know, so I can have my wall vector basically. Now, how do I go about like determining which one is vertical and which one is horizontal? Is by using the y component. Look at this one right here. So this thing right here, it starts there, and the final point, which is over here, doesn't have any modification in 0. So we know that this is a straight 90 degrees wall, only because the y doesn't change. Now sometimes you get this in your game, and that is still a wall basically. So we need to have a little bit of threshold over there, bit of room to play with. So say this would still be considered as a wall, however the y is not the same from the start to finish. So let's go and code this real quick, simple stuff. I'm going to leave the debug draw array in there. I like it quite a lot actually. If hit.normal is smaller, is bigger than minus 0.1f, is that gonna work? Okay. If it's smaller than minus 0.2f, we're gonna be generous over here. And hit.normal is smaller than 0.2f, then we do have a wall. Why is that not working? Oh yeah, dot y, I'm sorry. Only on the y-axis. I don't care about the rest. We're looking for wall vector. Then we say wall vector is equal to hit.normal. And I'm going to be putting that into a if statement. Alright, let's have a look over here. We don't have any wall vector right now. If we collide with that wall, we do have one. Oh, amazing. Now, if I head back to my walking state, I uncomment these. Technically, if I'm just like relying on the code I had in the past, it should work. If it doesn't, then we're screwed. Hey, it works! Nice, so we have all this kind of stuff right here, amazing. As you can tell, the wall vector, if I just keep running towards it, the wall vector keeps getting cancelled out, and that's actually what we do in our code. That's the amazing part about our code. I'm gonna try and give you the example why we're running into this function, the kill vector function. Or why we have it, basically. It's actually gonna be quite hard to do. Okay, let's try something like this. Okay, so this is what happens when we kill the vector. We end up falling. Now, if we don't kill the vector, if we just go back and we comment this thing out. Oh, actually, we're gonna fall into a walking state and still kill the vector. Okay, let's go in the falling state as well. Here. So it's like it's really glitchy. And if I had like a bigger force, then I would really get stuck to that wall. Like if I try like this. Yeah, this is what we're trying to avoid basically. If I'm just holding the button like this, it just keeps like following this thing. Now if I drop, it gets stuck there. So this is why we need to kill the vector, so this kind of thing doesn't happen. So let's go back into walking. Oh, and we get the same problem. Okay, now I just look stupid. Okay, we're gonna have to fix that function. Am I still... I'm falling right now. That's the state I'm supposed to be in. I'm supposed to be falling. That doesn't look falling to me. Excuse me. But yeah, definitely some kind of improvement has to be done here, especially to the falling state. Let me go read a little bit of comment to look how stupid I am. Hey, what's up? Thank you so much for the comments. Hello from Algeria, you rock, dude. Thank you. Your def menu won't show in the endless runner tutorial. I really can't tell like the source of the problem with that little information. You should actually ask on the Discord so people can actually have a look at it. Sometimes when I'm by myself, it's hard to just keep up with everybody. Can you give me a shout out? Sure. Mud. I'm gonna butcher your name. Are you sure you want me to give you a shout out? Because I'm gonna butcher your name. I'm so sorry about that. You are from Malaysia. Mod Shawan Saidon. I don't know. I'm sorry. This guy right here. This one. Okay, cool. So I actually feel like we could be ending this quite soon. I'm going to be posting the code a little bit everywhere. It needs some changes, of course. It needs some improvement. So the bug you just saw, we can actually get rid of it. What I will be doing is we're going to be keeping this project for the next Funday. Funday being Sunday, by the way. If you didn't get it yet, it's Sunday Funday. Uh, which for me it's Sunday right now. I guess for you it's Sunday evening, but Sunday Funday for me is like in the morning. A Android PC, do you want to be a moderator? I'm not quite sure what a mod is, to be honest, and I'm not getting any spam right now, so maybe in the future, but right now I don't think we need one. Okay, cool. So I'll be ending this. All the code is gonna be on Discord in a moment. Actually, I'll be zipping this whole thing, this whole project all together. We're gonna be zipping it in a .rar file, right? So that's the start of our amazing controller. That's going to be a lot more amazing next week and then the week after and so on. Hopefully we can get some art along the way. If you guys want to actually send over art that we can use, like a character that moves, just make sure that you're okay with everybody using it. And if we can have some that art, that Gucci art put into the game, which is not really a game, but just going to be like a compilation of a lot of scripts everybody can use. That would be amazing. So I'm actually going to be ending on this. Let me quickly send this right on Discord, the whole project. So let's have a look at that. Funday. Right click on it. Add to fun. Oh, I can't use it. I'm still running the process in the background. Okay, let's try again. Funday is right here, and can I actually send it over Discord? I don't know. I don't know why Discord is being such a problem all the time. Okay, drag and drop. Can I put that right here? Okay, that's gonna be, we are Sunday, Funday the 30th. Upload. And yeah, so again, can you add your old project to with the full code? My old project is not working. I am not even, like, I didn't go and debug around it. Sometime I just go and I look at my old project, I grab code, and I forget to do what is it? I forget to do a copy. Sometimes I just cut it and I put it in my new project. So over the time I broke it, but it's like it's a big scrap of code that I just look at sometimes. But don't worry, the code is gonna get like a lot better next week and the week after. We're gonna go like progressive on that. A good 2 hours of streaming I think is fine. If we go beyond that, I might just go crazy. I'm not good at like keeping up my voice and stuff like that. Again, link of the Discord is in the description of this live stream. I'm going to put another one real quick in the comments so everybody can go grab the project if they haven't joined already. Make sure to use the programming help, and also if you can help the other people around you, that would be also very amazing. I see a lot of comments. I'm going to go through them really shortly with another cup of whatever I feel like drinking. And I will see you guys later. By the way, just on the side note real quick, if you have any video suggestion that aren't like super long, like, oh, go ahead and make this game. If you have like quick video stuff that you want me to make about Unity, just go ahead and leave a comment in a new channel. Why not? So suggestion. Boom. Leave it there. That would be amazing. Thank you so much again. This is a real time. I close this stream, and I will catch you guys next weekend and during the week if we're lucky. Goodbye.